electric field lines. What are the electric field lines? First of all, it was introduced by Michael Faraday. Okay. It was introduced by
Michael Faraday.
Introduced by Michael Faraday. Okay. And the second point is, it is an imaginary concept. It is an imaginary concept of visualizing electrostatic field.
Okay.
Electrostatic field graphically. Are you clear?
Yes, sir.
Yeah. Okay. The concept of electric field lines are generally used for visualizing electrostatic field. Okay.
Okay.
Or visualizing electrostatic field. All right.
Yes, sir.
Now, what are the properties of electric field lines? Let's see here. Properties. The first of the property is electric field lines. Just 1 second. Electric field lines starts from positive charge. It starts from positive charge and terminates at negative charge. And terminates at
negative charge.
Negative charge. Okay. Your positive charge is like this. Suppose that you have this positive charge, then electric field lines start from the surface just like this and going away from the charge particle. Okay. You can also say. It is also known as the source charge sometimes.
Okay.
Charge. Okay. Similarly, the negative charge, for the negative charge, electric field lines are terminating at the surface. Okay.
Okay.
This is sometimes also known as sink charge. Okay.
Yes.
Yeah. Note it down.
Okay.
Should we move on?
Yes, sir.
Okay. The next point is electric field lines never intersects. Electric field lines never intersects each other.
At one point.
Okay.
Yes, sir.
Like this, you have two field lines, just like this. But these
cannot intersect.
Yeah. Suppose that you have two field lines are passing like this, but they never intersect each other.
Yes.
Are you clear?
Yes, sir.
Yeah. So we can say more than two or infinitely many field lines can travel in the same space at the same time without affecting each other. Are you clear?
Yes, sir.
Yeah. And the next point is density of electric field lines gives an idea regarding strength of electric field. Regarding strength of electric field. Okay.
Yes,
if
sir.
The field lines are closer. Okay. If the just
Field
look
lines
at it. Suppose that you have many more field lines like this, and you are okay. You are choosing two different points in this field. Like this is your point 1, and this is your point 2. Okay. And just 1 second. This is your point 2. Then the electric field strength at this position is E1 and here E2. In the region of field strength of E1, you can look at here. In the region of electric field of E1 and in the region of electric field of E2.
Both E1 more strength. Yes, sir.
I mean density are different.
Yes, sir.
So we can say the field lines, I mean density of field lines gives an idea regarding the strength of electric field. At the position of at point 1, field lines are closer. Okay.
Yes, sir.
Field lines are closer. If the field lines are closer, then this is said to be the strong field. Okay. Yes. Yeah. And if the electric field lines are far apart, then the field is weak. Okay. Yes. In this case, we can say E1 is stronger than E2. Okay, sir. Are you clear? Yes, sir. The next one is point number 4. If you want to know or if you want to find the direction of electric field, then you should draw a tangential line, okay, on the curve. Suppose that a field line is represented by this curve and you want to know the electric field direction at a particular point, like at this point, then you should draw a tangential line, okay, at that point. And these tangential lines tells you or gives you the direction of the field, okay, at that point especially. Suppose that, so please note it down here. Okay. Direction of electric field is tangential to the field lines. Okay. This is your vector of E. This is also E. This is also E. Note it down, please. Okay.
Sir, can you pull up to point number 2 and 3? I have to do that, right?
2 and 3. Note it down first.
Yeah.
Okay.
Done. So done. So I can scroll down.
Yeah. Just 1 second. Yeah, this is your 4th point. And the next point is they exerts, or you can say they exerts lateral pressure which explains repulsion. Suppose that there are 2 field lines for the same type of charge, I mean same nature of charge, then they repel each other just like this. Okay, we can also say they exert pressure on each other. Are you clear?
Yes, sir.
Yeah. And the point next is, in between these 2 field lines, there is also a neutral point is found. This is a neutral point. Okay.
Yes,
And
sir.
you should remember that remember that electric field lines never cross neutral point. Okay.
Okay.
So please also write down about the neutral point at which net field is 0. Okay.
Okay.
Electric field lines never cross neutral point. Note it down, please. Note it down first.
Yes, sir. Done, sir.
Okay. Electric field lines. This is your next point. Electric field lines cannot penetrate into the conductor. Cannot penetrate into the conductor. And the electric field lines inside the conductor is, you can also write here, electric field lines inside the conductor is 0. Electric field lines inside the conductor is 0.
Okay.
Just like if you want to see this, then you can consider a positive charge. Okay. You can consider a positive charge like this. And field lines, just 1 second. Field lines start to go from
Positive.
away from the charge.
Yes, sir.
From
Outward.
the surface. Okay. They
Yes, sir.
never enter into the conductor.
Inside the surface.
Are you clear or not?
Yes, sir.
And the another important point is that they always make 90 degree from the surface of the conductor. Okay.
Okay.
They always make 90 degree from the surface of the conductor. So this is your another point. Electric field lines are always perpendicular to the surface. Note it down fast.
Okay, sir. Done, sir.
Good. Now we are taking a question. Draw electric field lines for isolated positive charge. The second one is for isolated negative charge. For C, two equal and positive charge. Sorry, two equal positive charge. You can write two equal positive charge. Okay.
Okay.
The last one is for uniform
Electric.
field. Please solve it.
Okay.
Please solve it.
Yes, sir. Okay, done, sir.
Okay. All of you have solved or not?
Sir, I've solved all of them.
Okay. Also, I am solving this. The solution of this question is for positive charge. It is like this.
Outward, it will be outward, yes, sir.
Yeah. And this is your part A. For negative charge, it is like
inside, inward.
Terminating.
Yes.
Okay. At the surface of charge. For the two equal positive charges, you have two equal positive charges like this. And the field lines are passing in just like this. Are you clear? I mean, they seems to be like exerting pressure.
Yes, sir.
Yeah. For the uniform electric field,
it will be straight line, sir.
Yeah, it will be straight line, or you can say they are parallel with each other.
Yes, sir.
Note it down. The next one is, sorry, electric field lines is over.
Yes, sir.
Okay. And now we will discuss about the electric field. Let's see electric field. What are the electric field? Electric field is the space surrounding a charged particle in which the electrical effect of that charge can be experienced. Okay?
Okay.
Yeah. It is the space surrounding a charged particle. A space surrounding a charge in which electrical effect of that charge can be experienced. Are you clear?
Yes, sir.
That you have a positive charge like this of Q, and the region or space created by this charged particle is this. Okay, then this space is said to be the field or electric field, you can also say, and this charge is said to be the source charge. Okay.
Yes, sir.
Electric field is a property of single charge. So also note down, it is a property. It is the property of single charge.
Yes, sir.
Okay. Note it down.
Done, sir.
Okay, good. The next point is electric field intensity. Electric field intensity, or you can say electric field strength. Okay.
Okay.
What is the electric field strength or electric field intensity? Okay. Electric field strength measures. Okay. Electric field strength measures the strength of the field at a particular point. Are you clear?
Yes, sir.
Yeah. So you can write here. It measures strength of the charge. Okay, inside the field at a particular point. Okay.
Okay.
Suppose that you have a charge and the field of the charge is this. This is your positive charge. Okay. And now we are keeping the another test charge at this position. This is your test charge. What is the test charge? Let's understand here about the test charge. Okay. The first point is infinitesimally small. Okay. I mean the size of the test charge is very small. If the size of the charge is small, then the strength also be small. Okay.
Yes,
I mean
sir.
the field created by this charge is just like this. This means the field created by this test charge is negligible as compared to the capital Q charge. Are you clear?
Yes, sir.
Okay.
Yes.
Strength is also very small. And the next point is it is always positive in nature. Okay.
Okay.
Positive. Always positive. Okay.
Yes, sir.
In nature. This is the property of the test charge. Are you understand it?
Yes, sir.
In this case, can you tell me, does this positive charge will repel the test charge or attract this test charge?
So it will repel, right?
It will repel. Why?
So because there are two positive charges, like charges.
Like charges, okay? So you can draw this like this, okay? This is your test charge. Test charge. The electric field strength, the formula will be E is equal to F over Q. Okay. What is the F here? F is the force experienced by test charge. Force experienced by test charge. This is a formula by the help of which we can measure the strength of the field at any point inside the field like A, B, C, or D. Are you clear or not?
Yes, sir.
This is valid for all type of configuration. For all type of configuration. Okay.
Okay.
And the SI unit of the charge is Newton per coulomb. This is a vector quantity also. This is a vector
quantity.
Note it down.
Yes, sir.
And also the another point, what will be the direction?
Outside.
The direction of E in the sense electric field intensity is same as that of force experienced by test charge. Note it down, please.
Okay. Done, sir.
Okay. The next heading is electric field due to a point charge. I mean, we are going to calculate the electric field due to a point charge.
Point charge.
Electric field due to a point charge. Okay.
Yes, sir.
Suppose that you have a charge of magnitude plus q. Okay. This charge is said to be the source charge. Do you remember or not?
Yes, sir.
And we want to calculate the electric field, electric field intensity at this point. Okay. And this is the point P. Are you clear or not?
Yes, sir.
And first of all, we should join these two, we should join the source charge to the point P. Okay. And then we will kept a test charge. And this test charge gives the amount of field intensity are available. Are you clear?
Yes, sir.
This charge will measure the electric field intensity at this point. And the direction of the electric field at this point is in this direction. Okay.
Yes, sir.
It is a force experienced by, first of all, force experienced by test charge due to electric field charge Q. We have already know our formula is E is equal to F over Q naught. Are you clear or not?
Yes, sir.
What is this F? This F gives the force acting between test charge and the source charge. Then first of all, we are going to calculate the value of F. What is F? F is your 1 over 4 pi epsilon naught Q into Q over R square and unit vector. Why? Because force is a vector quantity. This is your equation number 1. And now we have the value of force, then we can easily calculate the value of E. Okay. We can write here electric field of Q. E is equal to F over Q naught. What is the value of F? It is 1 over
1 by 4 pi epsilon 0.
Q into Q naught over Q naught. Sorry, Q into Q naught over R square over Q naught. Q naught is cancelled with Q naught. Finally, you got 1 over 4 pi epsilon naught Q over R square. Thus, we can say the magnitude of the electric field intensity at the point P is 1 over 4 pi epsilon naught Q over R square. Okay. Note it down, please.
Yes, sir.
This is in vector form generally. Okay. Because there is also a vector form. This is in the magnitude. Okay. Magnitude of the field. Note it down first, please. Hello. Hello.
Done, sir. Sir, you're on mute.
Once again, I am going to write this formula on the next page. Okay.
Okay, sir.
E is equal to 1 over 4 pi epsilon naught Q over R square. Are you clear?
Yes, sir.
Now from this relation, we can see here E is tightly proportional to 1 over R square also. Okay. Then what will be the graph between E and R? The graph between these two will be hyperbola. Which can you draw like this? This is your graph. You can draw this. Sorry. Okay.
Okay.
This is your E is directly proportional to 1 over R square.
R square.
And this is for
Hyperbola.
hyperbola. Okay.
Okay, sir.
Note it down, please.
Done, sir.
All right. Let's consider another example. This example is based on the graph charge plus Q is placed at origin. Okay. Then plot
Okay, sir.
E versus X graph for X is less than 0 and X greater than 0. We have a charge placed at this point plus of Q, O. This is your point E. I mean, the direction at this point is in this direction because the charge is positive. So the direction is always be away from the charge. Okay. And now in this case, you have already know if, this value of X is greater than 0 and this one is less than 0. For the X greater than 0, we know X is positive. And if X is positive, then electric field also be positive. But for X is less than 0, we can write X is negative. Then E also be negative. Thus, we can draw the graph between these quantities are like this. Okay. For X, for this part, this is your plus X and this one is your plus E. This is your minus X and this one is your minus E. This is your coordinate number 1. In coordinate 1, in the first coordinate, X is positive and E is positive. Both are lying like this. And X is negative and E is negative are found in the coordinate number 3. Do you remember or not? This coordinate is plus plus and this coordinate is of minus plus. Do you remember or not? This coordinate is minus comma minus, and this is plus minus. So the plot for x less than 0, sorry, the graph of x less than 0 will be like this. Okay, note it down first. Are you understand or not? Hello?
Yes, sir, I understood.
Yeah, okay, good. Note it down, please. Should we move on or not?
So 1 minute, sir. Done, sir.
Okay. The next point is superposition principle. The next point is superposition principle. Okay.
Yes, sir.
This is the next point, superposition principle. What is the superposition principle? I hope you have remembered the superposition principle of Coulomb's law. Just
Yes, sir.
similarly, in the case of every process is same around, okay, nearly Coulomb law. Suppose that you have different many charged particles.
Yes, sir.
Like Q1, Q2, Q3, and Qn. And the another charge is Q0. Then First of all, we should join all of the charges to the charge Q naught like this. Okay. This is your E1. This one is E2, E3, En. The separation between these are R1, R2, R3, and Rn. Then what will be the field due to the charge Q1? It will be E1 is equal to K Q1 over R of 10. Okay, square, or you can also say R1 square. First of, just 1 second. R1 square and unit vector of R1. Similarly, value of E2 is KQ over R2 square of unit vector of R2. E3 is KQ over R3 square unit vector of R3. For nth charge, En is equal to K Q over Rn square unit vector of Rn. Then what will be the net field? Net electric field at point P is equal to, E net will be equal to E1, E2, E3 up to the value of En. Okay?
Yes, sir.
Yeah. Note it down, please.
Okay,
You can
sir.
take a vector sign also because field is a vector quantity. Are you clear?
Yes,
So
sir.
you can write it also. Just I am coming in 2 minutes. Okay, please
Okay,
note
sir.
it.
Okay, sir.
Have you noted it?
So 1 minute, sir. Done, sir.
Okay, good. The another point is neutral point. What is the neutral point? Okay. Neutral point is a point at which electric field of point at which electric field of individual charges cancel each other. Okay. Also remember that electric force on point charge electric force on line charge electric force on point charge placed at neutral point is 0. Note it down.
Yes, sir.
Another point, neutral point doesn't exist for electric dipole. Okay.
Done, sir.
All right. Now we are going to calculate some questions here. All of these problems are based on symmetry. Okay. Or suppose that you have 2 point charges like this. You have 2 point charges like this. Okay. The charge at this point is plus of Q, and the charge at this point is plus Q also. Its center of these 2 charges is O. Then can you tell me what will be the net field at O? What will be the net field at O? You already know the field at O due to the charge Q1 will be in away direction from the Q1.
Yes, sir. Repulsion.
Clear?
Yes.
In away direction from the charge Q1, like this. And the the field due to charge Q2 is also away direction from Q2. This is your E2 and this one is your E1. And we have already know magnitude of Q1 is equal to the magnitude of Q2. If both of the charges are same, okay, then E1 is also equal to the EB. Sorry, E1 is also equal to the E2, which is equal to the KQ over A square. you can consider that both of the charges are placed at separation A from the center. Then electric field at O will be equal to the E1 minus E2, which is equal to the 0. Are you clear?
Yes, sir.
Note it down.
Done, sir.
All right. Next, three-point charge. 3-point charges. Suppose that you have a suppose that you have 3 charges placed at the vertices of a triangle. Placed at the vertices of a triangle. Okay.
Okay.
This is your of charge plus Q. This one is also of charge plus Q, and this is also a charge of plus Q.
Plus Q.
And the centroid is this. You can consider as O. You can join all of the vertices from the center also. Then what will be the net force acting at the center O? It also be 0. Do you remember in case of Coulomb's law? We have
Yes, sir.
already solved the questions. Okay?
Yes, sir.
Yeah. And the third point, we are taking the 4 charges and all of the 4-point charges. 4-point charge. All of the 4-point charges are placed at the vertices of a
triangle or square. Sorry.
Okay. In this case, once again, all of the charges of same magnitude, all of the charges of same magnitude, and they are passing through the diagonals. This is the point of O. In this case, once again, electric field at the center will be 0.
0, yes.
Okay. Note it down again.
Done, sir.
Okay. And now, electric field, concept of electric field is over.
Okay.
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 Our next point is electric dipole, which we will start in our next class, right?
Yes, sir.
All right. So we are going to over this class right now. Okay.
Yes, sir.
Thank you. Bye.